Yes, now I can hear you. Good afternoon from Shiraz. Thank you so much for joining at IRNOG6 meeting and accepting my invitation for giving your presentation.
Thank you.
If you can hear us, yes, now the screen is okay. So you can start, the mic is yours.
Okay. Hello, everyone. Good afternoon. And I'm so glad to be part of IRNOG this year. Thank you, Bilal, and thank you for the organizer to having me on this event. I'm really excited. I'm really inspired about what you are doing, guys, in Iran. Well done. Keep it up. So I'm going to share my slide. I'm not sure if you can see my slides, honestly. So I will just need someone from organizer telling me, go ahead.
Yes, everything is okay. We can see your slides.
Perfect. Okay. So my name is Sara Hassan. I work at Packet Clearing House. Today I'm going to give a presentation about building and operating a global Anycast network, especially for DNS. Before we start the slides, I just would like to give a quick overview about who am I. I used to be a network engineer at Sudan REN. I'm from Sudan originally. I used to be a network engineer, and then I started, my friend and I, we are the co-founder for Sudan NOG. So it's similar like Iran NOG, but that's for Sudanese people. So you can visit our website and join our activity. It's open for everyone, not only for Sudanese people. Now I work as the interconnection manager at Packet Clearing House, which is trying to reach out to network operator, internet exchange point, DNS admin or DNS operator, and try to work with them on our work. So what is we're going to see now. And also part of outreach team for Quad 9, 9.9.9.9. I hope some of you heard about it, and I hope some of you is using it. If not, I'll also give an overview about it during my slides. So what is PCH and why, what we are doing? Packet Clearing House, it's used to be a research and non-for-profit organization based in US, but honestly, we're working with them all around the world. We don't have like a preferable location. The main mission for PCH was like we are believing on internet should be better for everyone, and it should be equal access for everyone. So we always try to keep this mission by providing support, either by training, by workshops, by equipment, by lots of kind of support for government, for the community initiative, for anyone who believe in our mission and would like to help their community. And we also believe there's some kind of critical internet infrastructure that's really going to make an effect in the internet, which is internet exchange point and DNS operators. So that's why since 1994, we are really focusing on these two sides or two aspects. But now we are having like a multiple aspect, like doing with the government, CERT, and a lot of things. And you can see more details about PCH in our website, pch.net. So when I say we are providing Anycast DNS services to IXPs and DNS operator, what does that mean, or what we are doing in our infrastructure? What we are doing, we are hosting in our infrastructure around 400 top-level domain, including more than 100 country top-level domain. Either the main country or the main code for the country or the IDN. So for example, in my country, Sudan.sd, and we have .sudan with the Arabic letter. So both of them consider the CCTLD files. Providing also DNS infrastructure for two root servers admin. As we know, there are 13 root servers around the world. So we are collaborating with DNE teams to provide infrastructure for them so they can provide their services. Also, Quad 9 service, which as I just mentioned, Quad 9 is an open and free recursive DNS resolver that everyone can use and every network, every user can use it. What is special with Quad 9? Quad 9 is also non-for-profit organization based in Switzerland, which have a really tough user privacy rules. So that's why they register it there, because they believe that every internet user should have their privacy in the internet, and they should be able to explore the internet freely and without anyone tracking them or keeping records for yourself or what activity you are doing. So Quad9, they do believe about that mission, and they are also having some partnership with another organization like Cyber Security Alliance, which keeps them updated with a list of malware sites and all the bad things that we don't like on the internet. So they keep that updated, and if you are using Quad9, everything that is going to hurt you, or if you have a malware, for example, in your network, would like to stop that, using Quad9 will really help you to do this. They're doing a lot of work with network operators, with the countries, and I really recommend all of you go to their website, quad9.net, and read their blogs and their stories and case studies. They're really doing a great job with Malawi, for example. I was part of that project. So it's really good, and they will tell you how much of traffic that has been blocked from malware just in one big telecom company in Malawi. And they can do the same for other countries and other networks if they are happy. So please, if you don't use Quad9, start using it now. They have IPv4 and IPv6. So we keep saying Anycast, Anycast, and Quad9 Anycast. What is Anycast? So maybe some of you here are not aware about it, but if you are not, definitely you heard in your background, university or college or something, some basic network fundamental that all of us thought that one IP address or one public IP address should be unique on the internet, and never, you cannot have it in the same devices or same hosts, you're having the same IP address, otherwise it will be conflict, right? That's a little bit changed now. So Anycast is a network trick that can allow you to have multiple IP address, or sorry, you can have a same IP address in a multiple location, and all of them will be up and running at the same time. How you do that? It's just a network configuration site. You need to do it in your site, and everything will be, it will be done, nothing fancy. So how my users are going to access this IP address? Via BGP or via your routing system that you are using in your network. The network, you should configure it with the way that your user should be able to access the closest node to them, like nearest node to them. Nearest can be defined as nearest geographically, or depend on your routing table. Maybe your routing table C nearest should be in Europe and not in your country. So that's what we are going to discuss now. But it should be nearest to you. Nearest should be high preference for what inside your country, and after that, nearest geographical location. Where DNS is used, where this technology is used, the Anycast technology, it's used in a different DNS service. For example, it can be used in a timing protocol, for example. So a lot of services now, they are using this concept of Anycast to replicate their services around the world and having it all up and running. So it will give you higher performance, more reliability, resilience for your network. So it's really good technology, and it will give you a lot of good points or advantage for your networks. So where PCH is located, or the cloud, we can consider it. It's allocated, all these yellow dots you can see, it's around, now we are celebrating our 300 locations. So we are existing in 300 location or internet exchange point in more than 120 countries. You can see that, yes, there's still white country, or there's still white places. We need to work. We are still working on that, and hopefully we will cover this soon, especially with the recent change that's happening in PCH, which I'm going to give you later the good news. Okay, so how we measure our performance in the network, and how we check if the network in country X is using the resources that PCH providing inside the country. We have lots of course, monitoring tool and lots of things happening in background, but simple performance or simple experience, maybe you and everyone, every network can do in their sites. We are using a RIPE Atlas prop. I hope that all of you are aware about the Atlas Prop. It's an initiative run by RIPE NCC. They have a small prop device which run an open script, an open source. You can read about it and maybe you can change everything about it if you want. Having this in your network, you connect it to your network, will get one IP address from your DHCP server, and then you will be part, and it will be up and running, and you will be part of the global Atlas prop network globally. So you can run a measurement or anything from your network, or you would like to check how the words see your network. All these measurements you can run it through the Atlas Pro. It's really good. It's really good to have. Then what we are doing with that, we use the trace route, normal trace route we know in our network or in our knowledge to valid destination. We picked a valid destination. We wanted a reference where we make sure this reference is up and running. So when we run the measurement, we have a truth, or we believe that this destination is up and running in this time. The service is operating in this time. And this valid destination's reference is connecting or peer with the exchange point or with the route server, or if have some peers around it. So we picked our services, which is the DNS Anycast network that we are running, or Quad9, because we manage both of them and we know where we are exist, in which location we are up, and what's the service we are operating in each site. So the experiment I have done, it's as I said, it's just a trace route for Quad9 or for DNS. I did the statistic for not for a lot of location, honestly, just for UAE and for Bahrain. With UAE, where I base now, we can see that they have not a lot of Atlas Prop online, which is not really good because that doesn't give us a quick or a better view about how the performance is happening. So, but it will give you like at least a better understanding about what is happening. Maybe you can dive more and dig more to get more details, but general overview, it's okay. So you can see that those are on the left side, from my side, the prop ID. So there's a number of the prop ID, which we don't care about. ASN, this is what we care about. Those are the network. And then the minimum round trip time, or the TTL. Here we look for if the time for these services we are providing is make a sense, reasonable or not. We can see for the first one, for example, AS60924, the round trip is 0.3 millisecond, which is good. For all of them, they are green, not very bad, but we can see this yellow one. So I will give more detail about what's happening here. The first AS number, which was very green, and this is the top one, we are happy with that network. That's a good network. AS60924, it's connected to the exchange point. It's connected to UAE exchange point. PCH was also connected to UAE exchange point. And that network is using the resources locally. That's PCH providing inside the country. So that's good. We are happy with that. We are good with this AS number. What is the other AS number? AS number 3491. They are connected to the exchange point. They are connected to UAE exchange point, but they do not use the service that PCH providing inside the exchange point. Why? What's happening? Let's have a look. The first one, the good one, they're good. So this is the optimal scenario, and this is what we prefer to see everywhere. Like from one network, your traffic will go to the exchange point, and then will reach the destination. Only 3 steps. Well done. And you can see the time is few millisecond, 0.5 millisecond, 0.4 millisecond. That's reasonable. And think about it, this is a DNS services. This is a small queue of DNS. So you don't need your DNS to have like a milliseconds to reach your destination. You're really hurting your customers if that happened. But let's say the other network, 3491. They are in the exchange point, they are in UAE, and they are connected to the exchange point. But for them to get the PCH services, they prefer to send their packet to Singapore Equinix, which is PCHs also exist there, but they prefer to get the services, the same services we are providing to you locally, but you prefer to get it from Singapore than getting it from the local destination. From distance perspective, let's see, from geographical location, Singapore and UAE, that's a huge distance. That's more than 5,000 kilometers. So now you are hurting your customers. This ACE number is 3491, naughty, naughty, we don't like you. Because you prefer to send your packet 5,000 kilometers at least to Singapore and come back, and then you will serve it. And as I said, this is a DNS query. DNS query is a little tiny query. You don't need to do all that things. So this is one of the cases we can see in the around the world. Let's have another example. For example, Bahrain. Unfortunately, Bahrain, they don't have a lot of Atlas probe online, so they didn't give me like accurate results. But we can see these two Atlas or two Atlas probe in a different AS numbers. And we can see also they are green, but the TTL is not good, like 5 millisecond and 15 millisecond for DNS query. It's not the things we would love to see. Let's have more detail about what's happening also. So those are the ES number 5416. They are connected to Manama exchange point. PCH is also connected to Manama exchange point. So that's good. They are using the servers we are providing locally from the Manama exchange point. That's good. But let's see the other one, 39273. They are not connected to the exchange point, and they are preferred to use the service from PCH to UAE, from UAE IX, not from the world. Let's have a good more details about it. The first one, it's okay, not bad. Okay from the side that they are using the service locally. We are happy with that. Good point. But there is something wrong. Why the time for reaching the exchange point is 5 milliseconds? That's considered a lot, because from your network to the exchange point to PCH, that's only 2 hop and 3 hop if we consider the network of the exchange point itself. So something wrong. It should be similar, like we are connected directly together. 5 milliseconds for something connected direct, we don't like it, right? We all agree about it. So even though, yes, you are using the network or they're using the resources provided to you locally, make sure that you configure your network correctly so you can benefit from that. The second AS number, that's 39273. Those are okay. We are happy with them, but definitely we need to work with them. We are happy with them because they are not connected to the exchange point. So that's, so they need they need to send the traffic to their transit, and their transit need to pick which country I should go to. From Bahrain to UAE, that's a short country, you can drive. So that's a good location. Remember, we said Anycast, your BGB should consider where's the nearest one to me to get the resources from it. So from Bahrain to UAE, not bad to use the service, but we need to work with you. Like if the service is already provided at the exchange point, why you are not peering there, why you do not get it from there. So half. We are not, we don't consider it naughty, but it's 50-50%. Let's have a look to Iran. What's happening in Iran? First thing, let me say I'm very impressed about the number of the Atlas probe online in your country. That's really good. Keep it up. You are doing much better than lots of countries, as I already showed you. But unfortunately, all of them, they will be yellow. And we know the reason. We know the reason because we can see that. We know the reason why they are yellow, why the number and the time is very high, because PCH is not existing in Iran. And that's our fault. I'm sorry, we are not there, but we are coming soon, inshallah. So for now, why? Because we are not having any node inside any of Iran exchange point or any locations inside Iran. Most of the networks inside Iran, they prefer to get the service either from Greece, Athens, or from Amsex, Netherlands, or from Frankfurt. We don't like that too, because that is also, it's not only hurting like the Iranian network, but it's also, we don't prefer to get a lot of traffic from outside to one node. So for example, Frankfurt, we prefer to only serve that location. And we don't like to hurt other networks, because sending all the traffic around the world to come to Frankfurt and send it back, that is really bad. We don't like to see this happening. So hopefully soon we will be in Iran, inshallah, and then we can fix this, and then maybe we can do another presentation and put the before and after if we change this design. So as we see, this is like a simple idea about what's happening in the network, or what's happening for the performance for not only the network that peer to the exchange point, but you can run, as I mentioned, you can run a lot of measurement to measure lots of things. But these are like just simple experiment to see. We can see that different results happening. Why those are happening? Either the network do not peer at the exchange point, and this is what we can see in the case of Iran, for example. PCH does not exist in Iran, so we need to send the traffic through the transit link. Maybe misconfiguration, and this is what we saw in Bahrain, for example. We are connected in the exchange point. The service is already provided locally, but you still have a high latency to get or to reach your services. So definitely there is something wrong in your configuration. We need to work with you together and then debug that more. Wrong filter. That's a BGP filter. Lots of people, they don't set up their filter accurately or correctly. They prefer to set it with like maybe a specific number of prefixes that they need to get or accept, announce. They do not announce their traffic. They do not accept what the exchange point sending to them. Yeah, we can see lots of reasons that's happening, or lots of technical wrong filters happening. That's also generate a problem like what we can see now. Or bad routing politics, or the policies that the network is setting for their routing. It's also bad. That's why we see that in our big locations, for example, in Frankfurt, for example, Singapore, IRNOG6, Netherlands, all these locations, we can see that a significant amount of the traffic is coming from outside, not from the country itself. And because lots of people or lots of network operators think it's better to forward your traffic to a big UAE or big European exchange point, so your traffic will be routed there, lots of CDNs will be there. It's not the case all the time, because as I said, sometimes your service can be online in your country. If you did that, you are just hurting your customers, you are hurting the performance of your network. You don't get anything else. So those are the majority of the reasons, all of them consider on these parts. Because of that, we always have this message. Remember, set a local peering preference in your PGP should be higher than your transit. Your transit should be for something that you don't have access to. And remember, you are paying for your transit, so you always would like to keep your transit lower, so you don't pay a lot on that. If the service is providing locally, use a high preference for it locally. Advertising more specific to your transit will hurt you, because as we know, as a PGP talkers, more specific, more preferable. So don't do that. Don't announce your network as a / for example, 24 to your transit. That's going to hurt you, and you come and complain that I'm connected to the exchange point, I'm peer with you, but I still do not use it from the exchange point. Yes, because you are announcing it, or because you are doing it for BGP sites, wrong configuration, misconfigurations. This is what we told. You are announcing it more specific in a different way. So definitely you will not get it from the local site. Use modern tools to automate building filters, also from PGP side. There is a lot of tools. They are automated also for using AS set, not only tied for AS number or for number of the prefix that we announced. All these modern tools will help you to get better performance for your network. Also connect more Atlas broadband anchors. That will really help you, as I said, to do some kind of measurements and to see what's happening inside your network. And not only from your network, you can see that how the internet see your network, maybe from which side they prefer to upload, from which side they prefer to download, trace route, and lots of statistics. That's a general talk about what we are, like a daily use or daily work we are doing. So when we say that PCH have a global DNS Anycast network, where was those network, or where there's yellow dots that I showed you in the map before. We always prefer to connect to the IXPs, the Internet Exchange Points, because we do believe IXP is considered a neutral location. All the network they are connecting together, all the service will be provided to those network equally. No one will filter, no one will block you or something like that. So we always prefer to be in IXPs. And in Iran, we can see that there are like 3 exchange points, and they are really doing good work. And we are really impressed about what you guys are doing in your community. And we really wish to come soon and to connect on all of your exchange points so we can help you locally and change the figure that I showed you earlier. We always do these performance tests. As I mentioned, we have tools that can help us to see the measurement and the performance about each node. And we reach out to the network telling them like, you're doing good, well done. You are not doing good, please let us help you so we can fix this thing. Similar like what happened in, for example, Bahrain or in UAE or another locations. We always prefer to work with the IXP operators, as I said, because we think they are neutral. They don't think that we will be biased to one of these networks. Neutral, we provide our service always free and for everyone. So we prefer to work with them so we can get the best performance for all of them. So it will be a win-win for all of us at the end. We do have a limited resources also, so because of that, we cannot be present inside each network. We still have a few budgets, so having us to be in each network, that will be our dream, of course. But for now, as I said, IXP will consider the neutral places where we prefer to be. And of course, as I mentioned, that we would love to see the world changing. We don't need to see all the time that the traffic coming from Asia or from Africa, where I am, going to European and American countries. We don't need to see that. Now, world is changing. CDNs are everywhere. IXPs are everywhere. And now we can see that we would like to see this is changing. We do not need to send our traffic through the transit to somewhere else. We can always process our traffic locally. Okay, so the good news, we are not present at Iran. How are we going to fix that, or how we can fix that, or our plan? In August 2023, last year, we started the transition to be an international treaty-based organization. So that you can think about it, we are now becoming like a Red Cross, a global organization. We are not registered in one country. We are registered in a lot of countries. There are reliers, the PCH mission, and they are supporting that mission. So now we can be having, we can have a more privilege, and we can have more benefit to be operated globally. We can include and work with the country that we have issues working with. For example, some kind of sanctions, we cannot be exist there for some political reasons or things like that. So now this is going to be non-exist anymore. So we are happy with that. So we can be present in a different location and in a more location than it used to be. In my country, Sudan, we were always being under US sanctions, but we asked BZH to be present there. So my friend, he smuggled the equipment inside his luggage and sent it to Sudan. So we put it inside the exchange point. That's why we were becoming online in Sudan. But in Iran, as I mentioned, you guys are much you are a big country and you are doing a really great job, and you have 3 exchange points, and the traffic we can see it's more than 1 tera. So that's really good. So we cannot do that. We cannot smuggle also the equipment inside the luggage and come and put it inside, because we would love, when we set up a node there, for example, we would love to set up a big node to be able to handle all the requests coming. We would love to be in the 3 location, even more if we can. So that is going to be like, we need to do it properly. So that's why we are late. But hopefully by this treaty, we will be able to be present in, as I said, in Iran and in another location, most of the wide places, spaces that we saw in the map. So my last message to you, every time you as a network engineer or operator, every time you send a packet internationally for destinations that can be served locally, remember, you are subsidizing the internet ecosystem for your country. So please don't do that. Please use the resources you have locally. Try to keep your network performance high always. That's all from my side, guys. And I hope it was informative for you. And thank you for your attention. And if you have any questions, I'm here to help you.
Thank you, Sara, for sharing a lot of great ideas about the importance of peering and reducing the round-trip time between the end users and the services. As you already mentioned, we have big IXPs, larger-scale IXPs with more than traffic, but the point is the sanction, as you already said. Because of sanctions, we are not able to have peering in international IX, but hopefully maybe one day we will. اگر کسی از دوستان سوالی در مورد حالا پرزنت سارا در خصوص IXP داره، من میکروفون رو براشون بیارم. Just a few seconds, we have a question.
Okay.
Hello, and thank you for your presentation.
Thank you.
One of the things that I didn't notice was what is...
Sorry, Milad, I cannot hear well. There's a noise, so if you can just...
Yes, just a few seconds.
Okay. Sorry, guys.
Thank you for your presentation. And one of the questions that I have, and I didn't notice, what is the need to have one IP address for multiple devices?
Thank you, Milad. I need your help. I did not hear well. Sorry, I'm so sorry.
Yes, can you hear me well now?
I can hear you, but there is a noise. There is a fan or something like that. I'm not sure where it's coming from.
Okay, I will ask him to ask his question again.
Okay.
What is the need to use one IP address for multiple devices?
What is the need to use Quad 9? Is that what I heard?
One IP address for multiple devices. You mentioned in your presentation that we can use one IP address for multiple devices across multiple locations.
Yeah. Okay. If I got your questions, what is the benefit from using one IP address in a different location, right? Is that correct?
Yes, yes.
Okay. The idea of having that, or the benefits that you will get from it, is you don't want your first thing. Imagine that you are providing your service with one IP address. Let's say Quad 9, 9.9.9.9. Imagine if that one device is located in one country and something happened to that one device. Everyone around the world setting 9.9.9.9, the service will be unreachable to it, right? That's the first thing. Second thing, there is no resilience. What if that network hosting this IP address decided like, no, I'm not going to provide it locally anymore. I will not go providing it globally anymore. It will be only for my customer. So other networks, they will not be able to access this. So the benefit of it, it will provide a performance, as we mentioned that when you have it in a different location, that means that your network can prefer always which one is nearest to me so I can get it. So that will be, the time will be very, very few. Other thing that, as I mentioned, if something happened to one node, there is millions of nodes around it and it's still up and running. So imagine if our DNS service is only, or the root service, for example, if it's only one IP address in, as we can say, in US, one IP address in RIPE NCC offices, one IP address, and something happened to all of these things, we will not be able to access we will not be able to explore the internet. So that's why the Anycast services are here, or they has been, what do we call, people invented. So we can have resilience, better performance for network, and it can help that whenever everyone would like to have it inside their locations or inside their country, they can have it. You don't need to be tied with one entity or one organization around the world. As I mentioned, it's used by DNS because DNS is considered one of the critical infrastructure. Timing, for example, time protocol. We always know about, all of us know about NTP, for example. We would like to have different location for timing. We get it from, maybe this side has been down this time, we can get it from another side. So it's considered good for some services, like where we need to get better performance and accurate. So that's why it's invented.
Okay, thank you. Thank you so much, Sara, for your presentation. Have a great day ahead.
Thank you. Thank you, Bilal.
Bye-bye.